Well, hello everybody. This is from the 8.1 discussion post. I ask you to solve this by completing the square, and that's quite a chore. Now, completing the square is a technique that's going to reappear in 8.6 and 8.7. Now, a lot of you in the discussion posts in 8.1 use the technique taught in 8.2 to solve this. That is, you use the quadratic formula, and it works, of course. Both techniques will work with any quadratic equation. But we need to make sure we understand this technique of completing the square. And so I'm going to solve it that way. And the idea there is we need to get the first two terms of the trinomial together. So I'm going to subtract 6x from both sides and add 3 to both sides. And when I do that, this is what I get. Keep in mind I'm subtracting 6x from both sides and adding 3 to both sides. You see, now what I've done there is I've got the first two terms of a trinomial. And the idea is to run this technique of completing the square and create a perfect square trinomial on this side, and then to factor it, and then to take the square root of both sides. And you'll see that as we go. The technique says, though, that there's one absolute requirement, that the coefficient in front of the x squared term has got to be a 1, and it's not here, it's a 6. So I'm going to factor out a 6 from both of these terms, and that gives us this situation. I'm just working with the left-hand side, so nothing gets done over here. And now I'm going to go ahead and divide both sides by 6. And when I do that, the 6 vanishes on this side, and we have 3 divided by 6, which is the same as 1/2. So now I have the first two terms of a trinomial, and the coefficient is 1, and I'm ready to run the technique now for completing the square. And what that says is that we're going to add something to this that's going to cause this thing to crack into two identical halves. And what is it we add? Well, the technique says you take the coefficient in front of the x. In this case, it's a -1. You take a -1, you rip it out to the side over here, and you do two things to it. First, you divide it by 2. And I want you to pay attention to this number because we're going to see it again. We divide it by 2, and then we square it. And when we run that rubric, we end up with 1/4, and that is what we add to both sides of the equation. So we have to add it to both sides because when we add it to this side to create a perfect square trinomial, we've changed the equation. I've added a 4th over here. I need to add a 4th over here, and 2/4, that is 1/2. 2/4 plus 1/4 is going to give me 3/4. So I'll go ahead and do the arithmetic as we go. Now, this is a perfect square trinomial. And that's from chapter 5, cracking these things. And we've created one that actually will crack like this. And that's why I wanted you to pay attention to the number inside here, because it reappears over here, like so. If we were to multiply this out, we would get this trinomial back. And the thing about this is that this is two binomials and they're identical, so I could write them in their shorthand style like this. And then, of course, we still have the 3/4 over here. So that was the whole game, was to get to this point right here where we had a perfect square trinomial and we could factor it. And the reason why that's so important is because we're going to take the square root of both sides. I'm going to run this thing through the square rooter. And remember, when you take the square root of both sides, you drop a solution, and so you need to put the plus minus in. You drop the minus solution, you need to put the minus in there to recapture it. So I'm running both of these sides through the square rooter. And the square root is going to undo the square. And so on this side we have x minus 1/2. You see, I come to this point now where I can solve for x, and that'll be my final step. I'll add 1/2 to both sides. So that's what this was all about, was getting this x binomial squared so that I can run the square rooter against it and isolate x. So over here now we have 3/4, the square root 3/4, and the bottom is a perfect square. 4 is a perfect square, so I can write this as plus minus square root of 3/2. And now I'm going to add 1/2 to both sides. And so really that's the solution. Adding 1/2 to both sides, I get 1/2 plus minus square root of 3/2. And for sure we can combine these fractions because they have common denominators. And so this is an okay answer. It's perfectly legit. And so is this, following the arithmetic on top and showing the common denominator on the bottom. Either one works. So that's the technique, and this was a highly involved problem. Not easy, and that's why I don't see it attacked too much, and I can understand that. The quadratic formula is is for many of you much easier way to tackle this problem. But again, completing this square, we'll see it again in 8.6 and 8.7. Okay, I hope that helps.